So we talked yesterday about the law of cosines. So I want to review the law of cosines and law of sines today. There is a quiz out there on oblique triangles for today. So we'll end a little bit early to give you some time to work on that. Again, that's just law of sines and law of cosines. So let's look at our different possibilities that we have for solving triangles. I'm going to look at this possibility here. I'm going to label it ABC, little a, little b, little c. And I'm going to give you this angle here is 58 degrees. We'll give you this side down here is 61 inches. And I'll give you that this side over here is 70 inches. Now, again, obviously not drawn to scale, but there is an important thing here. First of all, we do have a side and its opposite angle. So since we have a side and its opposite angle, or an angle and its opposite side, whichever way we want to look at it, we can use the law of sines. We must have that combination in order to use the law of sines. However, in this case, we do have two sides and one angle. And whenever that's the case, we do have to be a little bit careful. We have to make sure the side that is opposite our given angle is the longer side. And here it is. This is our given angle. That would be the opposite side. 70 is longer than 61. And we'll look at examples coming up here as to why that's important that we know that. So let's set up our law of sines. We have the 70 inches over the sine of the 58 degrees equals our 61 inches, and that will be over the sine of its opposite angle is angle B. And we'll cross multiply and divide here. Sine of 58 degrees times 61 inches divided by 70 inches gives us 0.7390. Well, that is the sine of B. So to find B, we have to do an inverse sine of that 0.7390. Second sine, 0.7390. I should have do this. Second sine of that previous answer, so I don't have the round off error, at 47.65 degrees. So angle B is 47.65 degrees. Makes sense because side B, the 61, is a little smaller than side A of 70. So this angle better be a little smaller than angle A, a little bit smaller than the 58 degrees. So 47.65 degrees here. Now we can find angle C simply by subtracting from 180. So I'm going to do the 47.65 plus 58 is going to give us, what, 105? Yes, not 115, just 105.65. Then we subtract that from 180, giving us 74.35 degrees. And now we can find side C by repeating our law of sines. We're still going to use the 70 inches over the sine of 58 degrees. Now we're looking for side C over the sine of the 74.35 degrees. And yes, we're going to cross multiply and divide. 70 times the sine, 74.35. Make sure you close that sign before you divide. By the sine of 58, we get 79.48 inches. Now remember, there are two checks we should always perform here. One is the obvious one, is the longest side opposite the largest angle, and that is true. And is the smallest side opposite the smallest angle? That is also true. So that's the first thing we should always check. The second thing we should always check is to make sure that the two smaller sides, in this case that's the 70 and the 61, add up to be larger than the longest side. 70 plus 61 is 131. That's definitely bigger than 79.48. Again, that's not guaranteeing we did it correctly. It's just helping us to avoid making some really bad mistakes. Well, another possibility was to have two angles. I might be told that this here is 68 degrees, and this one over here is 51 degrees, and one side. And it doesn't matter which side we have. I'm going to have this included side here between the angles. I'm going to tell you that this is 28 inches. Now, the first thing we do not have is a side and its opposite angle. But we can find the third angle. Anytime we have two angles of a triangle, the third angle is just a couple of steps away. We do the 68 plus 51 gives us 119 degrees. 180 minus 119 gives us 61 degrees. So we know angle B is 61 degrees. Now we do have a side and its opposite angle. So we're still able to do the law of sines. We have our 28 inches over the sine of 61 degrees. And typically I will always go, here we don't have a second side, so it really doesn't matter. But we would always try to find the smaller one first. So I'm going to use the sine of 51 here because it's a smaller angle. And A up there. We'll cross multiply and divide. 28 times the sine of 51. Make sure you close that parentheses. Divided by the sine of 61. Give us 24.88 inches. A is 24.88 inches. We would repeat that pretty close to the exact same proportion. Find side B. Unless we side B up here, and it'll be over the sine of 68. It's not side B, it's side C, sorry. We side C up here, and it'll be over the sine of 68 degrees. And we cross multiply and divide. 28 times the sine of 68 degrees divided by the sine of 61. We got 29.68. Once again, longest side opposite our largest angle, smallest side opposite our smallest angle, and the two small sides, 24 and 28, are 52, add up to be larger than our largest side. Rather than to continue drawing out triangles, I'm going to set them up this way here. Now I'm going to tell you here that the angle A is 53 degrees, side B is 38 inches, and side C is 45 inches. If I were to draw this triangle out, you would find that the angle that we have is between the two sides. So the angle is between the two sides. That is what we call the included angle. This is where we have to use the law of cosines. Remember, this is c squared equals a squared plus b squared minus 2ab times the cosine of c. However, here, it's not angle C that we're given, it's angle A that we're given. So in our formula, we're going to exchange A and C. So this, instead of being c squared, this will be a squared equals instead of a, it's going to be c squared plus b squared minus, instead of 2ab, it's going to be 2cb, and this will be the cosine of angle A. As we mentioned yesterday, we always want to do this here part as one big piece. So let's get the numbers put in there first. So c is 45, so that'll be 45 squared, plus b is 38, so 38 squared, minus 2 times 45 times 38, times the cosine of 53 degrees. So we're going to enter all this whole section in our calculator all at one shot. 45 squared plus 38 squared minus 2 times 45 times 38 times the cosine of 53 degrees, close parentheses. This is the only time we should hit enter or equals throughout this whole calculation. 1410.79. Notice that I am again leaving that in the calculator because that is a squared. I have to square root that to find a. The second square root of that answer, 37.56. Side A is 37.56 inches. And now I do have a side in its opposite angle. So we would set up for our law of sines now. It'd be the 37.56 over the sine of 53 degrees equals, and I'd pick a side. Normally, remember, we pick the smaller side, the 38, over the sine of its opposite angle is B. So we will cross multiply and divide there to find B. The reason we chose the smaller side here, the 38 instead of the 45, is so that we know that angle B is going to be smaller than angle C. So we know that angle B has to be an acute angle. Sine of 53, close that parentheses, times 38 divided by 37.56. You get 0.8080. And we'll do the inverse sine to get the angle B. 53.90 degrees. And of course, then we subtract to get angle C. We subtract from 180. One more example I want to review before we look at some other things. If I give you here that angle A is 29 degrees, side A is 42 inches, and side B 70 inches. We have two sides in one angle, and we actually have a side and its opposite angle, so we're good to use the law of sines. However, this is the case where we had mentioned that we need more information. We need to know if angle B here is acute or obtuse. If I tell you that angle B is obtuse, that means our picture is going to look something like this. Here's angle A of 29 degrees, side B of 70 inches, side A of 42 inches. And we see angle B is going to be an obtuse angle. So we go to solve this. It's still just law of sines. 42 inches over the sine of 29 degrees. That's side A over angle A. Equals 70 inches over the sine of B. And we're going to cross multiply and divide. Sine of 29, make sure you close that parentheses, times 70 divided by 42 gives us 0.8080 as the sine of angle B. And then we will do the inverse sine of that to get one of our possible angles for angle B. Remember, there are two angles that have that same sign. So when we do the inverse sine of that 0.8080, the calculator is giving us one of those possible angles. It's saying B might be 53.91 degrees. Well, that's the acute possibility. And the obtuse possibility, we would take that angle 53.91 and subtract it from 180 degrees. It's the supplement. That's going to give us 126.09 degrees is the obtuse possibility. So angle B is really 126.09 degrees. And now, of course, we can subtract from 180 to get C, and we can find side C using the law of sines. I can't emphasize this enough, that you have to make sure you know if what you're looking for is an acute angle or an obtuse angle. Sometimes the picture isn't enough to tell. In this picture, it seems obvious that B is obtuse, but it's not far off from a right angle. So make sure you know if the angle you're finding is an obtuse angle. You have to take this extra step to take the angle that we find from the inverse sine, and we find its supplement to get the actual angle. Because remember, inverse sine only gives us one of the possibilities for that angle. There's always two for an inverse sine. So let's say we have a lake. And I want to find the distance between point A and point B over here. I'm not going to can't take a surveyor's wheel and roll it across the lake, to be honest. And to run any sort of measuring device, you'd have to cross the lake. But we can do an indirect measurement. This is an old surveyor's trick, doing an indirect measurement using our laws of sines and cosines. So I'm going to construct a triangle like this where I can access points A and B easily from a third vertex. And I measure these distances. Let's say I find this distance here to be 482 feet. And this distance over here to be 411 feet. And I come back here, this is going to be called my point C. I use a theodolus to sight to both of those locations from that spot, and I get an angle between those two lines of sight, between here and here. I get that angle is 34 degrees. Well, I can now find this length across here, that distance from A to B, because that's just side C of my triangle. This is a law of cosines problem. C squared equals A squared plus B squared minus 2 AB sine of C. So I can fill in my information here. C squared equals 482 squared plus 411 squared minus 2 times 482 times 411 times the cosine of C. Again, we're going to do this whole piece over here as one big long calculation. We're going to enter it in one string in the calculator. No, not going to hit enter until we get to the very end. So 482 squared plus 411 squared minus 2 times 482 times 411 times the cosine of our angle of 34 degrees. I didn't put that in there. I got to put that 34 degrees in there. You get 72,776.998. I have to square root that. I can square root of that number. 269.77. So that's 269.77 feet. 269 feet. Nine inches. And 4/16, so a quarter inch. 269 feet, 9¼ inches is the distance between those 2 points. Well, that is our laws of sines and cosines. They're out there for you to use. There's, like I said, there's several applications in finding missing pieces. Anything you can turn into a triangle now doesn't have to be a right triangle anymore. You can find the missing parts of that triangle. One of the applications this comes into is vectors. One of the things that we use in vectors is called a Maxwell diagram. And the Maxwell's diagram is basically just drawing out the vectors to see where they match up. But let's say that we are supporting here. Let's look at a hanging weight. And we're going to make it so it's hanging a little uneven here. Let's say we are hanging 200 pounds. And I know that this angle here is, let's call it 49 degrees. Actually, let's call it 42 degrees. And this angle here at the horizontal, let's call it 71 degrees. So we have three forces here from this point. We have the 200 pounds pulling down. We know the direction of that is 200 pounds straight down. Then we have this one pulling up there 70 degrees from the horizontal. So I'm going to draw it like this here. This is 71 degrees. So that means this angle here would be the complement, or 19 degrees. Then we have this one here, goes like this. That's going to be 42 degrees from the horizontal. So the complement here would be 48 degrees. So this angle right here can be found. 48 plus 19 is 67 degrees. 180 minus 67 is 113 degrees. So to find the stress on each of these ropes, I'm going to label this rope A and this rope B. So this is A and this is B over here. I'm going to erase that 42 degrees. This is a law of sine situation. I have my 200 pounds over the sine of 113 degrees. I can find the force on A over the sine of 48 degrees. So we'll cross multiply and divide. Find A. 200 times the sine of 48 degrees, close that parentheses, divided by the sine of 113 degrees gives 161.46. So remember, this represented this rope right here. That's 161.46 pounds. Find this piece up here. It'll be the 200 over the sine of 113 again, equals B over the sine of 19 degrees. So again, it's cross, multiply, and divide. Well, it's now 200 times the sine of 19 degrees, close the parentheses, divided by the sine of 113. We get 70.74 pounds. So that, remember, this piece here corresponded to this side, 70.74 pounds. Now notice those two do add up to more than 200, and the smallest side is opposite the smallest angle. So what this is saying is that rope, or support or whatever, is a rope, cable, chain, whatever, that's steepest is going to be supporting most of the weight. This one here is supporting some of the weight, but it's mostly just pulling it off to the side a little bit. So vector analysis, and we're not going to do any more vector analysis until if there's time at the very, very end of the semester. It all depends on how our timing goes here in our next unit. The next unit very well could chew up the last 6 weeks of the semester here. We mentioned law of sines, mentioned law of cosines. What about law of tangents? Law of tangents is a thing. Law of tangents can actually be used in place of, in the exact same situation as the law of cosines. It comes into effect when we have something like this. Let's say I know that this angle here is 58 degrees. I know that side A is 60 feet and side B is 49 feet. I know, not drawn to scale. The law of tangents says that the ratio of A minus B to A plus B is equal to the ratio of the tangents of A minus B over 2 to the tangent of A plus B over 2. Now, this form is not horribly useful, but we can adjust it a little bit to get this form. The tangent of A minus B over 2 is equal to A minus B over A plus B times, now we're multiplying by this tangent of A plus B here over 2. We can actually convert that into a cotangent, if we would like to, of C over 2. A plus B over 2 is going to be, C would be the supplement of that. But by the fact that we're dividing by 2 means it adds up to 90 instead of 180. So C would be the supplement of A plus B, but when we divide them by 2, C over 2 is the complement of A plus B over 2. The total would now be 180 divided by 2, or 90 degrees. So this is the cotangent, not cosine. So it's the tangent of the complement. The reason I change it is we know what angle C is, so I can put that in. So we now have here the tangent A minus B over 2 is equal to, well, A here is 60, B is 49, so 60 minus 49 over 60 plus 49 times the cotangent, keep putting cosine, not cotangent, cotangent of 58 degrees over 2. I can calculate, this whole side can be calculated out. In fact, I can do an inverse tangent on it, and I can do something just flashed on my screen. I don't know what that was. I do an inverse tangent and then multiply by 2 to get A minus B. So let's calculate that out. I'm going to calculate this side over here. And to do that, I'm going to do the 60 minus 49, which is 11. 60 plus 49 is 109. Times the cotangent, tangent. 58 divided by 2 is 29 degrees. First, I'm going to do the cotangent of 29 degrees. Remember to do cotangent, I do the tangent, I do the reciprocal outside of the parentheses. Gives me 1.8. So times 11 and divided by 109 gives me 0.18206. That is equal to the tangent of a minus b over 2. I'm going to do an inverse tangent to both sides now to get rid of this tangent here. So inverse tangent, second tangent of that previous answer, gives me 10.32 degrees. A minus b over 2 is 10.32 degrees. And now I can multiply by 2 to get rid of that dividing by 2. So I get a minus b equals 10.32 times 2, so 20.64. Make sure that's how it multiply out. So multiply up to 20.64 degrees. So a minus b is 20.64 degrees. So you might be thinking, well, how does that help us much? Well, because I know from angle addition, a plus b plus 58 degrees equals 180, because that's the sum for the whole circle. So that gives me that a plus b equals 122 degrees. That's 180 minus the 58. Well, this is now a system of equations, and I know how to solve this system. It's set up to solve with elimination or addition real quickly. A plus a is 2a. Negative b plus positive b cancels out. 20.64 plus 122 is 142.64. To solve for a, we divide by 2. A is 71.32 degrees. So we found angle A here, 71.32 degrees. And then we'd find angle B would simply be, what is that going to be? 50.68 degrees if I subtract from 180. But why would we ever want to use the law of tangents? The only benefit to using the law of tangents is I was able to find both of these angles without ever having to find side C. Well, there's never really a case where we maybe don't need side C, but it doesn't hurt us to find side C. And to me, it's way easier to use the law of cosines to find side C and then use the law of sines from there to get these angles. So there really is no benefit to this law of tangents, which means it's really kind of useful to us. Now, I have checked to see if there's a law of secants, and I can't find anything on it. I've never seen a law of secants out there, and I can't find anything on it when I try to look it up. So really, law of sines and law of cosines are the only things out there that are useful to us. So I realize we have another hour left, but I wanted to make sure you guys had plenty of time to practice and do the homework here, and plenty of time for that quiz. So remember, there is a quiz out there to do on those oblique triangles. There's going to be one page of homework. This is out of the big book. Page 926 through 930. Exercise 36-8. 7 through 27, the odd. This is applications of law of sines and cosines in problem solving. So make sure you go through them, because it is often difficult to figure out what am I going to use law of sines or law of cosines. So make sure you've gone through at least several of those problems. Also remember, Thursday is our next unit test. It's actually posted out there already. I will log into class and see if anybody has any questions. If nobody is here, I'll probably only stay logged in for about 10 minutes and then I'll disappear. But on Thursday, the only thing we need to do is to finish that test. Now, if you have questions on this quiz, stop in on class on Thursday and I'll help you with that quiz if you need me to. Otherwise, make sure you get that test done. So I may not see many of you on Thursday. Also remember, on Monday, April 5th, so that is next Monday, I will be gone. I am taking some of my personal time on Monday. So I won't be here on Monday. There will be no class on Monday for you guys. So for many of you, I won't see you again until next Tuesday. So you guys have a great weekend. Have a good Easter.
Thanks, Todd. You too.
Thank you.